Gas discharge tubes. Thyratron tubes. While gas discharge lamps are more commonly used as sources of illumination, their hysteretic properties were leveraged in slightly more sophisticated variants known as Thyratron tubes. Essentially a gas-filled triode tube, a triode being a three-element vacuum electron tube performing much a similar function to the N-channel, D-type IGFIT, the Thyratron tube could be turned on with a small control voltage applied between grid and cathode, and turned off by reducing the plate-to-cathode voltage. In essence, Thyratron tubes were controlled versions of neon lamps built specifically for switching current to a load. The dot inside the circle of the schematic symbol indicates a gas fill, as opposed to the hard vacuum normally seen in other electron tube designs. In the circuit shown above, the Thyratron tube allows current through the load in one direction. Note the polarity across the load resistor, when triggered by the small DC control voltage connected between grid and cathode. Note that the load's power source is AC, which provides a clue about how the Thyratron turns off after it's been triggered on. Since AC voltage periodically passes through a condition of 0 volts between half cycles, the current through an AC-powered load must also periodically halt. This brief pause of current between half cycles gives the tube's gas time to cool, letting it return to its normal off state. Conduction may resume only if enough voltage is applied by the AC power source, some other time in the wave's cycle, and if the DC control voltage allows it. As the AC supply voltage climbs from 0 volts to its first peak, the load voltage remains at 0, no load current, until the threshold voltage is reached. At that point, the tube switches on and begins to conduct, the load voltage now following the AC voltage through the rest of the half cycle. Load voltage exists, and thus load current, even when the AC voltage waveform has dropped below the threshold value of the tube. This is hysteresis at work. The tube stays in its conductive mode past the point where it first turned on, continuing to conduct until the supply voltage drops off to almost 0 volts. Because Thyratron tubes are one-way, diode, devices, no voltage develops across the load through the negative half-cycle of AC. In practical Thyratron circuits, multiple tubes arranged in some form of full-wave rectifier circuit to facilitate full-wave DC power to the load. The Thyratron tube has been applied to a relaxation oscillator circuit. The frequency is controlled by a small DC voltage between grid and cathode. See figure below. This voltage-controlled oscillator is known as a VCO. Relaxation oscillators produce a very non-sinusoidal output, and they exist mostly as demonstration circuits, as is the case here, or in applications where the harmonic-rich waveform is desirable.